Bismillahirrahmanirrahim. Today, inshallah, we will talk about 4 very special segments in a triangle. There are 4 special segments in a triangle. Okay, today I'm just going to talk about some of their salient characteristics, some basic features, their names, etc. that we need to know, and then we shall elaborate on these in the future, inshallah. So, I have drawn here 4 triangles, each of them illustrating one of these 4 segments. Okay, the first here in the first triangle, okay, this is a perpendicular bisector of this particular side. Okay, so what I have here is, let's call this triangle A, B, C. Okay, and then let's call this point right here point M, which is the midpoint of this segment. Okay, and this segment right here that I have drawn, okay, is the perpendicular bisector of this segment AC. Okay, so the first special line is the perpendicular bisector. Okay, perpendicular bisector. Now we've met the perpendicular bisector before. Now this is just an extrapolation of the knowledge of the perpendicular bisector to triangles. The second special line here is the angle bisector. Okay, we've also met the angle bisector before. So, and this right here is the angle bisector. Okay, so this is the angle bisector. I'm going to write that over here. Okay, and the third special segment that I believe we have not met before is a segment that's called the median. Okay, a median is a segment that connects the vertex from one side to the midpoint of the other side, like this. Okay, so this is the midpoint right here, and this segment connects the vertex B to the midpoint like this. Now notice this is different. Now perpendicular bisector, okay, is perpendicular and goes to the midpoint. So if I were to superimpose the perpendicular bisector over here, it would be kind of like this. Okay, all right, okay, and this would be like perpendicular. So there's a difference between the perpendicular bisector and the median. The median goes from the vertex to the midpoint. The perpendicular bisector goes to the midpoint and is perpendicular to that segment. Okay, so they are different. Okay, now also if you observe over here, I said segments, but I seem to be kind of like drawing lines over here, right? Correct. So the segment would be the ones that are like this, but you can also say there are 4 special lines that are in a triangle. Okay, so but know that this is a median that goes from the vertex to the midpoint. And the last one is a segment that connects the vertex to the opposite side and is perpendicular to it. It's like the perpendicular distance from the vertex to this opposite side, and this is the altitude. Okay, also just to be sure that you appreciate, the altitude is not the same as the perpendicular bisector, which is also perpendicular to the side, but it goes through the midpoint of the segment over here, right? Like that. Okay, so perpendicular bisector and altitude are not necessarily the same. Okay, so these are the 4 special segments or 4 special lines that are associated with a triangle. The first here is a perpendicular bisector. The second one here is an angle bisector. The third one is the median, and the fourth is the altitude. Now you notice that I drew the perpendicular bisector over here, okay, for this particular segment AC, right? But then there are 3 sides to a triangle, right? So this one has a perpendicular bisector too, right? So if I were to draw the perpendicular bisector over here, okay, kind of like, you know, let me see if I could draw it. Okay, let me see. It's going to look like something like this. Okay. Okay. Let me just draw it, and so you see something quite interesting. All right. You make an interesting observation when you do that. And this is the perpendicular bisector from this side. Okay, like this. So let's label these two sides congruent like that. And then if you do the same thing for the third side, you notice something quite remarkable. So here's the bisector. This is the perpendicular bisector for the third side I'm going to try to draw. So it's going to go look like this. And what's really remarkable, as you can see here, is they all meet up here at one point. They all intersect at one point. In other words, all the perpendicular bisector of the triangle, all three of them, okay, they do something quite interesting. Okay, they meet up, they intersect each other at one point. Now, if you have any two lines, they'll intersect someplace. But for three line segments or lines to intersect at the same spot, that's quite remarkable. This phenomenon of intersecting at the same spot, okay, that's called concurrency. So the perpendicular bisectors of a triangle are called, they're concurrent. C-U-R-R-E-N-T means they all intersect at the same point. So the three perpendicular bisectors of a triangle are concurrent. And the point that they meet up at, that's called the point of concurrency. So the point of concurrency right there. Okay? Well, if we do the same thing with the angle bisector, let's see what happens if we do the same thing with the angle bisectors. So we go from here. I'm going to try to bisect this angle over here. Okay, that's that. I try to be reasonably accurate here. Okay. And then these angles are congruent. And finally, I bisect this angle over here. I've done that wall, and then you notice again something quite remarkable. What you noticed again for third is that the angle bisectors are also concurrent, which means they all intersect at one point, and that point is called the point of concurrency. Okay, it's called the point of concurrency. Now, these are given names, these points of concurrency, but we won't talk about them because it kind of gives away the highlight of the whole conversation. So we'll hold off on that. So it's quite amazing. It's coincidence, you say? I don't know. But angle bisectors are also concurrent. Let's see what happens if we do the same thing with the medians. So let's take the medians. Let's take this A and connect it to the other side. The median is the segment that connects the vertex to the other side, the midpoint of the other side. And then let's see what happens if you connect this one over here. Well, if I could do it properly, whoa. And again, we notice the same thing. The medians also appear to be concurrent. The medians are concurrent. Wow. I think you're kind of getting the idea, and that's the point of concurrency. Now, the altitudes, and I think you guessed that they are also concurrent. Okay, so if I draw the altitude, which is the segment from the vertex to the opposite side and it's perpendicular to that side, it's kind of like the height of the triangle from that side. And finally, if I take this altitude over here, and lo and behold, you see that that altitude is like this, and the altitudes are also concurrent, and that's the point of concurrency. Okay, so we have learned something quite remarkable. Altitudes are concurrent. So this was a way of introduction, and as a way of introduction, I suggested to there are four special segments or lines in a triangle. The first one is the perpendicular bisectors, and if you connect the perpendicular bisectors of the three sides of a triangle, draw them out, they are concurrent. That means they intersect at the same point. And then we talked about the angle bisectors, and lo and behold, the angle bisectors were concurrent, and there was a point of concurrency there. The medians are concurrent. Medians is the segment that connects the vertex to the midpoint of the opposite side, and they were concurrent. And the altitudes, which is the segment connects from the vertex to the opposite side and perpendicular to it, and they too are concurrent. Now, I hope you appreciate there's something special going on over here, and we shall explore these special segments in much more detail next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.